Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is Vitamath 38 still on cyclic quadrilateral so that you will be able to master the information, formulas, and properties of cyclic quadrilateral. So a cyclic quadrilateral has sides AB 30, BC 18 units, angle A 80 degrees, and the diameter of the circumscribing circle of 50 units. So determine the area in three methods. Also determine the perimeter of the cyclic quadrilateral. Actually, there are so many ways to compute the area of a cyclic quadrilateral. As of the moment, since I haven't yet derived other important theorems on cyclic quadrilateral and I haven't yet derived the formulas, let's have the basic approach and the properties of intersecting chords of a circle and the fact that area of a quadrilateral is area of one triangle and area of another triangle, and the area of the triangle is one half product of adjacent sides times sine of the angle included. So here is the cyclic quadrilateral, which is inscribed in a circle from the preceding Vitamath problem about cyclic quadrilateral. So side AB is A, which is equal to 30. BC is B, which is 18. And we have unknown sides C, CD, and AD. And angle A is 80 degrees. And we learned that the opposite angles of cyclic quadrilateral are supplementary. So if this is 80 degrees, the other angle there is 80 degrees. If you can find angle B, then angle D would be 180 degrees minus angle D from the preceding uh, Vitamath problem, Vitamath 37. So everything is discussed there. So R is 25. And if we form this diagonal AC, so this is side C, this is side D. Then we have diagonal AC. So this triangle ABC is inscribed in a circle, and this triangle ADC is also inscribed in a circle of radius 25. Remember from sine law, the ratio of any side of the triangle to sine of the angle opposite it is equal to 2r, or the diameter of the circumscribing circle. Since A is known and B is known, we can compute this angle. I'll call this theta A1. So 18 divided by sine of theta A1 is equal to 2r. So 18 times sine of theta A1 equals 2r. Likewise, if I call this theta C1, the angle between this side BC and this diagonal AC, then the ratio of 30 and sine of theta C1 is equal to 2r. So we can compute theta A1 and theta C1. From there, we can compute this angle here, which is 80 degrees minus theta A1. And again, triangle ACD is inscribed in a circle. So the ratio of C to sine of this angle here, 80 degrees minus theta A1 is equal to 2r. So we can compute side C because we have found theta A1 from the preceding mentioned ratio 18 over sine theta A1 is 2r. Then this angle here is 100 degrees minus theta C1. After computing theta C1, Then the ratio of D and sine of this angle here is equal to 2R again, so we can solve D. So C and D can now be computed, then we can compute the perimeter of the cyclic quadrilateral. Now, the area of the cyclic quadrilateral in terms of the sides is supposedly there is a formula for that, square root of S minus A, S minus B, S minus C, S minus D, but I will not use it here because I haven't yet derived that. For the meantime, we'll just use the information, the fact that the area of the cyclic quadrilateral is area of one triangle plus area of the other triangle. So area of triangle BAD, for example, plus area of triangle BCD, because the angles are known and the sides have been determined as mentioned earlier. So first, 18 over sine theta E1 equals 2R, 2 times 25. So theta E1 is equal to, using your calculator, 21.1 degrees. Likewise, 30 as to sine of theta C1 is equal to 2R, 2 times 25. So 30 divided by 50, inverse sine, then we have theta C1 equal to 36.87 degrees. So knowing theta A1 and theta C1, we can now solve side C and side D. For side C, C over sine of this angle, and this angle is equal to 80 degrees minus theta A1, is equal to 2R. So C over sine of quantity 80 degrees minus 21.1 degrees is 2 times 25. So side C is equal to 42.81 degrees. Then D, because this is also a triangle CAD inscribed in a circle, as to sine of this angle, which is 100 degrees minus theta C1, is equal to 2 times 25. So side D is 2 times 25 or 50 times sine of 100 minus 36.87, and that is 63.13 degrees. D is 44.6 units. Then the area of quadrilateral is equal to, cyclic quadrilateral is equal to area of triangle BAD. By the way, let's solve for the perimeter first because we have found C and D. So 30A plus B 18 plus C 42.81 plus D 44.6. So the perimeter is equal to 135.41 units. Then for the area, first way, so let's divide the area into area of triangle BAD and area of triangle BCD. In the preceding Vitamath problem, Vitamath 37, that area is set up as 1/2 of product of adjacent side times sine of included angle. And remember that sine of 80 and sine of 100 degrees are equal, or sine of an angle and sine of its supplement are equal. So that's why the area is simply 1/2 quantity AD plus BC times sine of 80 degrees or 100 degrees. That's the same. Then the other area would be 1/2 of quantity AB plus CD, then times sine of angle B, where angle B is equal to 180 degrees minus theta A1 minus theta C1. We have found theta A1 and theta C1, so you can solve angle B. Angle D, there's no need because it is the supplement of angle B. The formula is the same because the area is in terms of sine of one angle. So again, area is 1/2 AD, area of triangle BAD plus area of triangle BCD. Then area of BAD is 1/2 A times D sine of angle A. Then BCD, the area is 1/2 BC sine of angle C, where sine of angle A is equal to sine angle C, so that's why I'll just use sine angle A here. So 1/2 AD sine angle A plus 1/2 BC sine angle C, and sine angle C is just sine angle A. So substituting, because everything is known, area of cyclic quadrilateral is 1 half of 30 times 44.6 plus 18 times 42.81 sine of 80 degrees. So area of cyclic quadrilateral to four significant figures is 1038 square units. Then for the other formula or other calculation of area, the second approach would be 1 half the product of the diagonals. Remember, for the general quadrilateral, 1 half product of the diagonals times sine of the angle between the diagonals. Now, which angle? There are two angles. It doesn't matter again because the area is 1 half product of the diagonal sine of one angle here. And the other angle is the supplement of this angle here. So if we call this uh, theta, by the way, angle B is, as mentioned earlier, 180 degrees minus theta E1, 21.1, minus theta C1, which is 36.87 degrees. So angle B is 122.03 degrees. So there's no need to use angle D. It is the supplement 180 degrees minus 122.03 degrees, and that is 57.97 degrees. So, but anyway, that's not needed. Then the diagonal AC can be computed by cosine law. So area of cyclic quadrilateral, another method is 1 half the product of the diagonals times sine of theta, where theta is the angle between the diagonals. So whichever angle, this acute angle or this obtuse angle, it doesn't matter because sine of theta and its supplement are the same. So let's call this theta. And that theta, remember from principle on intersecting chords of a circle, theta is 1 half the angle, 1 half the angle occupied by its subtended arcs. There are two arcs subtended, AB and CD. Then theta is 1 half the angle occupied by arc AB, which is this angle here, central angle here, plus 1 half the angle occupied by arc CD, which is the central angle CD, which is this angle here. So this is theta AB and this is theta CD. So theta is 1 half quantity theta AB plus theta CD. So 1 half of quantity theta AB plus theta CD. Where theta AB, which subtends arc AB, which is also the same arc subtended by theta C1, or this angle here. So theta AB, therefore, by principle on central angle and peripheral angle, theta AB is 2 times theta C1. Remember, this is the peripheral or inscribed angle, theta C1, which subtends arc AB. This is the central angle, and the relationship is the central angle is double that peripheral, corresponding peripheral angle. Then theta CD is this angle occupied by arc CD, which is subtended by this angle here. And this angle here is 80 degrees minus theta E1. Therefore, theta CD is 2 times this angle, 2 times 80 degrees minus theta E1 by principle again. So I hope that with this explanation and uh, properties of intersecting chords of a circle from preceding Vitamath problems and this cyclic quadrilateral, you gain many important concepts and informations about cyclic quadrilateral and the intersecting diagonals or chords of a circle. So, by the way, by cosine law, to solve for diagonal AC from triangle ABC, so diagonal AC square is equal to 30 square plus 18 square. Remember cosine law, minus 2 times 30, 18 cosine of angle B. So times cosine of angle B, which is 122.03 degrees. So diagonal AC can now be computed. It is equal to 42.39 units. Then for the other diagonal, this diagonal BD here, it is either 30 square. So diagonal BD square is 30 square plus D square minus 2 times 30 times D cosine of 80 degrees. Or it is equal to diagonal BD square is equal to 18 square plus C square minus 2 times 18 times C cosine of 100. But I'll use 80 here, the original. You can check that if you use the other sides, B and C, cosine law in triangle BCD, the diagonal BD will be the same. So I'll use diagonal BD square equals 30 square plus D square, which is 44.6 square minus 2 times 30 times 44.6 cosine of 80 degrees. So diagonal BD is equal to 49.24 units. So the diagonals have been found. Then next is theta. So again, theta AB, which subtends AB as central angle, is 2 times this peripheral angle theta C1, which subtends the same arc AB. And since we have found theta C1, theta AB is 2 times 36.87 degrees. So it is equal to 73.74 degrees. Likewise, theta CD, this angle here, or this angle, central angle, is double this angle here, which subtends the same arc CD, but it is a peripheral angle or inscribed angle. And this angle is 80 degrees minus theta A1. Therefore, theta CD is 2 times quantity 80 degrees minus theta A1. So theta CD is 2 times quantity 80 degrees minus theta A1, which is 21.10 degrees. So theta CD is equal to 117.8 degrees. Therefore, this angle theta here is the average of angle theta AB and theta CD. So 1 half of 73.74 degrees plus 117.8 degrees. So theta is 95.77 degrees. So finally, area of cyclic quadrilateral, second way is 1 half into this equation. 1 half 42.39 times 49.24 sine of 95.77 degrees. So the area of cyclic quadrilateral, the second way, is 1038 square units also. Then the third way is area of cyclic quadrilateral is 1 half AB sine 1 half AB plus CD sine angle B. So area cyclic quadrilateral is 1 half AB 30 times 18, CD 42.81 times 44.6 sine of angle B. The explanation is area of triangle plus another area of triangle. 1 half product of adjacent side sine of included angle. So area of cyclic quadrilateral is equal to 1038 square units also. So that's it for this problem. I hope that for those who have not yet known about the characteristics of cyclic quadrilateral, your knowledge on cyclic quadrilateral is enhanced and added.